One common terminology you will come across when it comes to naming organic compounds is alkyl groups. But what are they? Well, before we go into discuss what alkyl groups are, please subscribe to our channel if you haven't done that yet so that you wouldn't miss these interesting lessons. In an earlier lesson, we already discussed how to name straight-chain alkenes. I hope you remember. If you haven't watched that lesson yet, we'll leave a link to it under the description of this video so that you wouldn't miss it. Or better still, you can check the playlist that we already have on organic chemistry. So what are alkyl groups? Well, if you look at the definition we have on the screen, alkyl groups or an alkyl group is basically a fragment of an alkene. A fragment? Yes, a fragment of an alkene formed by removing one hydrogen atom. You might say that word sounds familiar. Fragment. Does that mean it's a piece of an alkene? Well, yes, we can say that. So, what does that really mean? Look at the example we have on the screen. CH4. This is an alkene, a classic example of an alkene, the simplest alkene available. One carbon bonded to 4 hydrogens. This is an alkene. But suppose you are able to cut one hydrogen out. The hydrogen to the left, you are able to cut it out. Then you have CH3. That is an alkyl group. Is this not simple? Yes. That's all what you mean by an alkyl group. So this is an alkyl group. If you have a close look at it, you can see they have C with 3 hydrogens. Then there is a dash behind the C. What does that mean? Well, that means alkyl groups are monovalent groups. What does that mean? Monovalent means that they can make one bond and are commonly found as substituents in larger organic compounds. Monovalent. They have the ability to form one extra bond. So that line that sticks out tells us that this alkyl group can be attached to larger organic molecules. I think that makes sense, right? Because the hydrogen has been cut off. The place occupied by the hydrogen has been removed from the main alkene. Specifically for this example is methane. So the hydrogen has been removed. So there's now an empty space for it to bond with a larger organic compound. Now, how do we name alkyl groups? So I'm going to take you through it step by step. But before then, just look at this table. So for the table, we have carbon atoms 1 to 4, alkane name. Remember we said alkyl groups are formed from where? They are formed from alkanes. So to get an alkyl group, you first need to have an alkane and then take a hydrogen out or cut one hydrogen from it. Then you will get an alkyl group. Ready? So let's look at, we've already looked at the first one in an earlier slide, that is methane. When you cut the hydrogen from it and you now left with CH3, that is a methyl. So now let's focus on the carbon number 2. So that's what we have on the screen. 2-carbon alkane is known as ethane. If you don't know how to name straight chain alkanes, I'll urge you to watch that video because it has already been uploaded. If you haven't watched it yet, you can check the description of this video to have access to it. So this is ethane. Suppose we cut one hydrogen from this, it becomes what? Ethyl. So what does that mean? In order to name an alkyl group, look at the spelling of alkyl. A-L-K-Y-L, right? So to name an alkyl group from a certain alkane, just take the name of the alkane group and remove the A and E and replace the A and E with YL. Think that is simple and fair enough, right? Let's look at the next one. The compound we have on the screen is propane. Why is that the case? We have 3 carbons with how many hydrogens? With 8 hydrogens. That is what? A propane. Suppose we cut one hydrogen from the propane. What would we end up with? We'll end up with propyl. propyl, we remove the A and E. That tells us it is an alkane, and replace it with YL, which means it's now an alkyl group. I think that is correct, right? Well, that makes sense. So if you look at the formulas we have down there, C3H8 has now become C3H7 because one hydrogen is missing. And beside the C, we have a dash to tell us that this alkyl group is monovalent and is ready to go into bonding with a larger organic compound. Let's look at some more table of alkyl groups. So your responsibility is to know the alkyl groups. I've just explained to you how the names came up with. So an alkyl group formed from methane is called methyl, and the one formed from ethane is ethyl. And these are the formulas out there. So the natural methane should be CH4, but because one hydrogen has been removed, it's now CH3. So you can go through methane all the way to tert butyl. Tert butyl. Well, don't worry, we have some quite explanation for here. We have propyl and isopropyl. But before we look at propyl and isopropyl, I want you to do something for me. Look at this. The formula we have at the top out there, that is C3H7. What does that mean? Come back to the propyl and look at the formula. The formula is dash CH2, CH2, CH3, right? Let's count the number of carbons. You have 1, 2, 3. 3 carbons out there. That is why it is CH3. Let's count the number of hydrogens. We have 2 plus 2, that is 4, plus 2, 7. Good. So we have C3H7. Good. So it's just the same thing. So naturally, that is a propyl. So how come we now have isopropyl? It's isopropyl because the molecular formula is the same. It is still C3H7. Look at the isopropyl. Let's count the number of carbons and see. For the first carbon, we have CH. They have brackets open, CH3, and then there is a 2. What does that mean? CH, one carbon attached to the H, right? Now look at the open bracket. We have CH3 inside the open bracket, and when the bracket is closed, there is a 2. That 2 affects every atom inside. So the 2 affects the number of carbons inside. So we have the carbon is in the CH3. We have only one carbon out there, but because of the 2 in front of the bracket, meaning the carbons are 2. So 2 plus the earlier 1 carbon gives us 3 carbons. Make sense? Of course. What about the hydrogens? Inside the bracket, we have 3. 3 times 2 is 6. 6 plus 1 is 7. So the formula of isopropyl is the same as propyl. But why is it called isopropyl? Why is it called isopropyl? Like I said earlier in an earlier video, the naming has already been given to us by IUPAC. But we have to explain and then keep it in mind. Why is it called isopropyl? You see the 3 carbons present. 2 of them are attached to only 1 carbon. Look at the 2 hydrogens or the 2 CH3s. They are attached to a single central carbon. So if you have this kind of arrangement where CH3, 2 of them are attached to 1 carbon, that makes it an iso. So it can be iso something, isopropyl or isobutyl or iso something. I think that makes sense. So propyl is the N propyl or normal propyl. They have what? Isopropyl. So we've explained propyl, right? Now let's explain the butyl. Because we have butyl, isobutyl, and tert butyl. Let's move to the next slide so that we can focus on butyl. This is what we have for butyl. Butyl is obtained from butane, right? Yes, that makes sense. Butyl from butane. So it is butane and 1 hydrogen has been stripped off. So butane is C4H10. But when 1 hydrogen is stripped off, it becomes C4H9. It shorts 1 hydrogen now, right? So that butyl is known as N-butyl. The N stands for normal. So this is the regular or normal butyl that we have. But look at the interesting thing. Now we have isobutyl. It is also C4H9. Isobutyl is still C4H9. You can count the number of hydrogens. You see that we have 9 and the number of carbons are 4. Why is it isobutyl? Look at CH3. The two CH3s out there. They are attached to one carbon. That makes it isobutyl. Got it? Good. What about tert-butyl? For tert-butyl, instead of two CH3s attached to one carbon, we have 3 of them attached to what? One carbon. That makes it tert-butyl. And why is it still butyl? Because we still have 4 carbons. So tert-butyl. Because it's still C4H9. So for C4H9, we have N-butyl, there's no normal butyl, we have isobutyl and tert-butyl. These are the various variations of the alkyl groups that can come out from a single formula. Does that make sense? Well, if it doesn't make sense, maybe it's because this is the first time you are hearing it. And as the normal way the brain works, when you guess or hear something for the first time, it might be difficult for you to quite understand it. But the more you watch and learn and practice, your brain gets used to it, and then it becomes easier for you to remember it next time. So this brings us to the end of our lesson on alkyl groups. Now we are ready to name branch chain alkanes, because we need to understand what alkyl groups are and then name branch chain alkanes. So in branch chain alkanes, what are we to expect? Well, we'll define what branch chain alkanes are, look at some examples of them and what side group means, and then apply the knowledge of alkyl group in naming branch chain alkane. So see you in our next lesson.